Hey, what is going on? What is this? It's the second part of the pattern recognition final project of me, and this video is about how we use the data features generated by the last video and put those features to train our classifier and generate a well-trained classifier and do the prediction. So in the last video, okay. In the last video, we have our raw data here, and we have our clean data, which is processed by the NLTK, the Natural Language Toolkit, and we use tokenize and also steamer to clean those data. And also after this, we use scikit-learn, the counter vector, and we put those clean data into a space vector module. So this instead is a list of fixed lanes. So this sorry, these lanes can be put into the classifier because they are numpy array, they are lit, they can be put into the classifier. And after this, we give each element of those things a weight value generated by the frequency and also the inverse direction. Directory frequency. This kind of thing that generate it put a weight value on the word that happens very frequently. So those words are likely to contain specific important information because they happen in every piece of data in this data set. So there's a sample of top 100 features with highest term frequency. So the term with a high term frequency are usually not very useful. Coffee, chocolate, sugar. So that you cannot tell the review is positive or negative. Only you know the word like a coffee. So after this, the next step is to put these things into our classifier. So we have let me run again. So I run already. Okay. Let me train it. So when we start training, we're going to talk more about our classifiers. So we have those 5 where it is. Okay. We have those 5 classifiers. There are 2 of them are non-Bayesian. One of them is linear model, and last one is the support vector machine class, and it's SVC. For the first one, for the naive Bayesian class. So what is naive Bayesian class? So the key assumption of naive Bayesian is that we have our input database and we have our training data X. So we say that X is a d-dimensional value. So what's the value of d? Maybe 1,000 or 10,000. I don't know. But it's a d-dimensional value. And we have our classification value Y is a variable. So how are we going to predict a Y from X? We need to compute the joint distribution, the joint probability of X given Y. So we need to compute this, and during the computation, during the process that we get our joint distribution, we need to compute all the probability of X given Y, and X is a d-dimensional value. So how are we going to do this? That's a training result. So how are we going to do this? We make an assumption that each element of this d-dimensional X they are independent to each other. So they are conditionally independent given Y. So while we compute the joint distribution of the X given Y, just tell those things together and it just works because in the field of natural language processing, all the words that happens on data set, they are also related to each other. So they are the words that are used by humans are quite randomness, and so that's why we can use naive Bayesian. And second one is linear model. So it's very logistic regression. And so what's this one? So I said we are going to do the classification. Why we need a regression sim? So the regression sims works in this way that it generates a regression values, the probability. It generates a probability. It uses probability. We see that the value that has the probability of smaller than 0.5, they are negative. Value has the probability of larger than 0.5, they are positive value. So have this threshold value, and we have this probability. So in this way, we can do a classification using those two things. And as I said, the last one, the support vector machine. So what's a support vector machine? So the key concept in this support vector machine is hyperplane. So what's a hyperplane? It's kind of thing that is ideal. The ideal thing is the ideal line between those two clusters. We need to draw a bunch of lines between those two clusters to classify them. But how could we tell which line is the best line on all those lines? So the way we are doing this is that compute the maximum boundary of all the distance from the line to the nearest point of those two clusters. So it's like the line with a larger value of this minimum distance. It is far from all the two sides of the far from all two group of points. So that means it's a good line. And what we do here is that we try to compute the maximum boundary of this minimum distance. So we can generate an ideal plane. So we call it hyperplane. And plane. So using this ideal line, we can do the classification. That's how the support vector machine works. Okay, let's see the result of. So we got the result. This one, and it is a multi-meal naive Bayesian. And okay, this one is has a really interesting performance because you see the accuracy rate of the positive reveals is higher than the accuracy rate of the negative reveals. So it's not normal. It's not normal. For other classifier, the positive prediction accuracy is normally lower than the negative reveals prediction accuracy. So the same is lower. So I guess that in the negative reveals is the negative reveals they're pretty easier to identify than the positive review. That's why. But this one has a higher positive review prediction accuracy. It's very interesting. And one other thing we want to mention is that Bologna naive Bayesian that is not good as this one. So I want to mention that this logistic regression, that the regression algorithm. This one has really good performance. This one has the best performance among all 5 classifiers. The accuracy percentage is 0.95 and the error rate is 0.96. It's very high. And and so that's our data, our training data. So we have this diagram. So what is this diagram mean? ROC. What is ROC? ROC means that so this is a curve, and on two sides, the value on two sides TPR the true positive rate, and FPR the false positive rate. So why we use this tool? Okay, let me see. This one is a pretty good classifier, and the true positive rate of it, we draw a line here, is the true positive. So this is right. Forgot to mention that this right curve is a positive value. Also pixel instead of it as a positive value, and also pixel inside the blue curve has a negative value. So we draw a line here. The true positive value divided by all positive value is those thing divided by all those right thing, and it's already the value is pretty close to 1. And false positive rate, the false value is this bit divided by all positive value here. It's really small and close to 0. So this point is in this area. So, and it's a good classifier. You see, pretty separate. And for bad classifier, so we have this line here, we draw this line here. So what's the true positive rate? So it's like this area divided by all the right thing, and the false positive accurate. False positive rate is all the blue thing here. The false positive divided by the right curve here. This value pretty the same because they are so close. It's not good classifier. So the curves are very close to the center line. So you see that the curve that close to the center line, then it's not a curve belong to a good classifier. A good classifier should have a curve that's near the corner, and because it's near the corner, the area under the curve should be very large. So that's AUC, the area under the curve. So the logistic regression has the highest value of the AUC. So it's a really nice one. I told you that it's a really nice one. So that's the comparison part of it. So let me close. Another application is that we want to run this. We want to run this file classifier in real time. So we have those sentences. Okay, you see, will be okay. It doesn't fit me. It doesn't fit me. Python predict. We don't need to put this. It doesn't fit me. Python. The Python has no meaning here, but it's a negative review. We use 3. 3 is the best one. So the opinion is negative. And also we try another one. Delicious. Try delicious. This is pretty, should be pretty easy to identify. Use the first one, that is positive. And okay, I will buy it once again. Okay, we can read once, but I buy it again. So is this positive or negative? Let's see. Use 5 also very nice. Okay, it's positive. So that's our predictor is works very well, and all the 5 classifier works very well. So I like to see I like this project. So yeah, so I hope that you can see my video, and maybe see you next time.